This video is for lesson 3 of the GCSE waves topic entitled the wave equation. During the course of the lesson you will hopefully be able to recall what is meant by the wave equation, and then be able to use the wave equation to calculate things like frequency, wavelength and wave speed. We're going to start off by reviewing some of the stuff that we did last lesson in the form of a quiz. So you will need a rough book or rough piece of paper to jot down your answers. One or two of them require you to draw a diagram. So let's get going. Okay, first one then, question 1. I'd like you to sketch the two diagrams below very roughly and then indicate on them the direction in which the wave is travelling and the direction in which the coils of spring are actually moving, in which they're vibrating. 2, I'd like you to identify which of those two, A or B, is transverse. 3, which one of those two, A or B, is longitudinal. Question 4, I'd like you to copy out the diagram opposite and add to it one wavelength and one amplitude. Question 5, frequency is the number of waves made in 1 second. What do we measure frequency in? What's the unit for frequency? Question 6, find the time period of the waves opposite, and that's this diagram here that's just popped out slightly out of order on the PowerPoint, so it's this diagram here. Tell me what the time period is. Use the diagram to help you find that out, and then use the equation which will be given to you in the exam, frequency equals 1 over time period, to calculate the frequency. So pause the video now, have a go at those questions in rough. Okay, hopefully you didn't find those too difficult. Here are the solutions then. First off, the direction which the waves travel. Well, if you look at the position of the hand there, it's pretty obvious that in the top question, let's flick through the questions there we go. In the top one here, the waves will be travelling from left to right, and in B, they'll be travelling from left to right. However, there is a difference in which the particles vibrate. In this wave here, particles are vibrating in that direction, parallel to the direction in which the waves are travelling, and in this diagram here, coils are actually moving at right angles to the direction of wave travel. So given that then, which wave, A or B, is transverse? Well, the transverse one is whereby the waves travel at right angles to the direction which the particles are vibrating. So that would be B, and question 3, this diagram here represents a longitudinal waves because the particles are vibrating parallel to the direction of wave travel. Copy the diagram and label one wavelength. Well, the obvious one to go for is from peak to peak, but you could have had trough to trough. And one amplitude. There's one, there's one, there's one, and there's another. And remember, it's the maximum distance that the wave moves from the rest position. Be careful how you draw those in the exam. Frequency is the number of waves made in 1 second. We measure frequency in hertz. How many waves are shown in the picture? Let's count them. That's 1, that's 2, 3, 4, and that's 5. 5 complete waves. Now, the frequency is the number of waves made in 1 second. This picture shows a period of 2 seconds. So 5 waves made in 2 seconds means that 2.5 waves are made in 1. So a frequency of 2.5 hertz. You can tot up your marks there and give yourself a corresponding score. Okay, this next bit of work needs to go into your notes, hence the red little notice here, and you need to have the title The Wave Equation, which is what this lesson is all about. Okay, so the first thing to realise is the wave equation links the speed of a wave with its frequency and its wavelength in a very simple equation, which will be, you'll have to learn for the exam. Wave speed V equals frequency F times wavelength lambda. You can write that equation shorthand, and as long as you use the correct symbols here, that would be perfectly acceptable if you're asked to write down a relationship. Okay, just a reminder, the wave speed, the speed of a wave, is measured in meters per second, or m/s, not miles, m for meters there. F is of course the frequency measured in hertz, and lambda is the wavelength measured in meters. And you could be asked to swap that equation round, okay, to work out frequency and wavelength. So just remember that little triangle there. Okay, I would also like you to make a copy of the example in your notes, please. So the example question: calculate the speed of a wave if it has a wavelength of 1.5 meters and a frequency of 4 kilohertz. Now, as always with these problems, these mathematical problems, I usually get you to write down on the right hand side the information in the question. So you're going to do that, write down what you know. We know that the wavelength, given by the symbol lambda, is equal to 1.5 meters. The frequency is 4 kilohertz, but we should remember that frequency is measured in hertz, so we need to change that into hertz. Now 1 kilohertz is 1000 hertz. We've got 4 of them, so that becomes 4000 hertz. And v, the wave speed, how fast the wave's travelling, is what we're looking to find out. Okay, so on the left hand side, write down the formula that you're going to use, which should be quite easy today because we're only talking about one formula. V equals f lambda, wave speed equals frequency times wavelength. Put in your numbers, 4000 multiplied by 1.5, and then write down your answer with the appropriate unit. So the answer to that is 6000, and it's wave speed, so it's going to be measured in meters per second. Okay, again, in your books, please. I know it's a bit of a pain having to write down these questions, but it'll help you later when you're revising. Under the title Problems, can you make a copy of the 4 questions there? I've left for you on top here the triangle, which again won't be given to you in the exam, so don't be reliant upon that. Make sure you learn it. Okay, so I suggest that you pause the video now and that you have a go at those 4 problems, and I'll give you the solutions in a moment. Okay, solutions then. First one, V equals f lambda, wave speed equals frequency times wavelength. That should give you a very slow answer of 0.6 meters per second, frequency times wavelength. Likewise, this one here. Now the answer to this, 300 million meters per second, is really significant. We'll come see why a little bit later in the course. This one here, you have to work out wavelength, so you cover up wavelength, and it's wave speed divided by frequency, which gives you 0.2 meters. And finally, the wavelength again, cover up lambda, v divided by f, and you end up with an answer of 0.5 meters. Okay, hope those last 3 lessons have made sense. What I'd like to do now is to show me that you've understood that by attempting the Seneca exercises which I've set for you. If you've forgotten the class code or what have you, you can go to show my homework and have the class code there. You haven't joined the group. If you've forgotten your password, just simply log in again. Just create a new password and I'll sort that out for you. Okay, so by the end of today's lesson then, you should know that the wave equation links wave speed with frequency and wavelength. Learn the formula V equals f lambda, and you should be able to calculate wave speed, frequency or wavelength using the wave equation.